explanation for question number 7 out of 11 on the calculator section of the mathematics practice test. The question here says that if A is a non-zero real number and A times the quantity x minus 3 squared minus B is equal to C, they want us to prove that x in that equation must be equal to 3 plus and minus the square root of the quantity B plus C over A. Show your work. Type it into this text box. So this takes some practice using the drop-down menus that are available on the right-hand side here. You can get a fraction. You can access the fraction portion of this right here. The square root key is right here. There's a plus and minus in this equation. So again, this takes a little practice. I would get online and practice entering these equations and finding these symbols in the different menus that are available to you. To begin with, I'm going to start by typing the equation that was given to me at the beginning of the problem. And that is this. It says A is equal, A times the quantity x minus 3 squared minus B is equal to C. We need to solve this for x. They want us to show that x is equal to this right here. That means we need to get x by itself. So if I'm going to get x by itself here, my first move is going to be adding B to the other side of the equation. Okay? We always, if this was a problem that had a number there instead, if there were more numbers and fewer variables here, we always get the constants or the plain terms moved to one side first. So I would add B on both sides, and that would give me this. A times x minus 3 quantity squared is equal to C plus B. Okay, the next thing that I would do now is divide by the A on both sides. So I have x minus 3 quantity squared is equal to C plus B over A. And then my next move would be to undo squaring a quantity. To undo squaring something, you take the square root. And more specifically, you, in this case, take the positive square root and the negative square root. Okay, this little plus minus button over here is the thing I would type first, and then I would use the radical, the square root button, and put a fraction in so that I could type C plus B over A. Final step then is to add 3 to the other side of the equation. Sometimes you might see plus and minus square root of C plus B over A, and then a plus 3 written after that. However, they want it put in this form where the 3 is in front of that radical, so I've put it in front for this explanation here. So this, I think, is really a very end of the school year, more advanced type of question, probably appropriate for Algebra 2. I would question the appropriateness for an Algebra 1 test, but there it is. The square root of a negative number. The next thing says if A is equal to 2 and B is equal to 5, determine what condition or conditions on C will restrict the solutions for x to real numbers. Well, just as a basic introduction, I would say this first sentence here. Okay, the square root of a negative number would be an imaginary number. Okay, let me just a quick explanation there. The square root of 25 is positive 5, but there is a positive and a negative square root for 25. Okay, positive 5 and negative 5 are both square roots of 25. And that's because 5 times 5 is 25, and negative 5 times negative 5 is also 25. But if we tried to take the square root of negative 25, we would be looking for a number that you can times by itself to equal 25. And the problem with that is whether you take a positive number times itself or a negative number times itself, the product in that case is always going to be positive. You can't take any number times itself and get a negative product. So that's where imaginary numbers come into play. The square root of a negative number would be an imaginary number. So for this equation, we need the expression that's under this square root here. C plus b over a needs to be a positive number or 0 in order for this solution, in order for x to be a real number. Okay, so I said this, solutions to this equation will be real numbers as long as we are taking the square root of a positive number or 0. Therefore, the value of the expression c plus b over a must be positive, okay, or greater than or equal to 0. So that's what I based this on. If a is equal to 2 and b is equal to 5, so we plug this in, c plus 5 divided by 2, this expression here needs to be a positive number or 0, needs to be greater than or equal to 0, so that we're taking the square root of a positive number. I multiplied by 2 on both sides of this inequality, and it leaves me with c plus 5 is greater than or equal to 0. And I subtracted 5 on both sides to conclude that c must be greater than or equal to negative 5 in order for our solution to this equation to be a real number.